A very good evening to everyone. Today we are going to see about the topic of data structures. Data structures in the sense means the collection of elements, how far the elements have been getting stored in the memory locations. So that's for about the data structure. So for that, what type of algorithm we are going to use to structure the elements is the data structure definition. So in this how far the elements will be getting stored in the memory location is the main thing to be considered. So here, based upon the storage of the elements in the memory location, it is categorized into two main types, that is a primitive data structure and non-primitive data structure. The primitive data structures, which includes the basic data types as integer, float, double, character, and then the pointer. And then the non-primitive data structure is of linear and then non-linear. So the linear data structure in the sense means which contains a category of so these are the linear data structures categories: arrays, stack, queue, and then linked list. And then the non-linear categorized thing is trees and then graph. So we are going to see about what you mean by linear and then the non-linear data structures briefly in the next slide. So this is about the linear data structure. So here I have taken the example as for the linear data structure I have taken as array. So array here it is of one-dimensional array. You all know about for what purpose we are using the array. So if you are going to group the elements of the same category of same data type in the sense means, then we are going to collect all these elements of same data type in the form of an array. So here the array size is totally 6, starting from first index to till 6. The elements have been arranged contiguously without leaving any index. So this is at the bottom, the numbers is said to be the index number, and then inside the array elements will be stored. And then this is about the linked list format of linear data structure. So a linked list is defined as it is a collection of nodes is said to be a linked list. So each node is capable of holding two data fields. One is the element field, and then the other field is the next field. The next field used to hold the address of the next node. So with that address, it probably moves to the second node to point, and then in the second node here the data field, here in the second node the element field will be present as B, and then in the next field of the second node the address of the third node will be present. So with that the connectivity is established. So likewise it happens for D also. At last it is pointing to null because here no other node is there, so the address will be null. So this will be stored in the fourth node of D, the next field. So the next field will be of null. So this is about the linked list format of storing the data structures in linear part. And then this is of non-linear part. So you could ask me a question that what do you mean by linear and non-linear? So in the linear part the elements will be stored continuously without leaving any indices, but in case of non-linear part here the elements will be stored by leaving the memory addresses. I mean the index will be not the continuously one. So here for this representation you can take tree and then graph representation. So here the index will be marked here as 0, 1, 2, 3, and then here, and then next here is 3, and then 4. Fourth index is not present, and then 5, 6, 7, 8, 9. So likewise if we mod the indices, many indices will be considered as empty because the corresponding element is not attached to the index. So this is about the tree data structure. And then this is about the graph. So in the graph we have many types of graph, that is BFS and then DFS. Breadth first search and then depth first search we will be saying as popularly in the part of graph. So here we have vertices, and then all the vertices are probably connected through the edges. So this is about the simple explanation about data structures. Thank you.